Hey guys, welcome to the first lesson on the fundamentals of Java programming. This series is designed for a brand new programmer. We're going to be learning the fundamentals of programming, but specifically using the Java programming language. If you come from a language like C# or C++, this isn't just about learning the syntactical differences from these languages. But rather we're going to go into the details of object-oriented programming and talk about, like for example, in this lesson, like what a variable is. I'm not going to just show you the syntax for creating a variable, but I'm going to explain what a variable is because I'm assuming that everyone watching this video is brand new to programming and they want to just use Java as their first programming language. So we're going to first start off by just creating a new project. And to do that, we're going to go to File, New, and then we're going to say Java Project. Now, it's important to note the IDE I'm using is Eclipse. There are numerous IDEs that you can use for programming in Java. Two popular ones is Eclipse and NetBeans. I might switch between them throughout videos in this fundamental series. But for now, we'll start with creating a Java project using Eclipse. Both of these IDEs are free, so you can download them both for free. So yeah, we're going to start off by creating a Java project. And when you do that, this dialog is going to pop up. In the dialog, we're just going to set a project name, and I'm going to say this is just lesson 1. And then I'm going to hit finish. Now when that happens, it's going to load my lesson 1 in my package explorer on the left hand side. I'm going to go to the source file, right click and hit new, and I'm going to add a new class. I'm going to name my class, this is just my source code, I'm just going to call it source for now. And then make sure if you're doing this that the public static void main method is clicked here so that you don't have to create it yourself. This will create the main function. And the main method, as you can see, which is this is what gets generated by clicking that checkbox. This is the entry point to a program. The main method is the entry point of a program. And this applies to C++, C#, and Java. So the main is the entry point. So that's where we're going to start writing our code to start off. So the first place that I like to normally start off with all beginner programmers is learning what this concept of variables are, how do we declare variables, because essentially managing data and holding data is one of the most important things of programming. We need to learn how we can hold data efficiently, and we need to sort of just understand that this data is here, we can change it, we can do anything we want with it. We have these storage locations. Essentially, we have RAM at our disposal to store some data. So let's start off by defining a variable. I normally define it as a variable is a named, and that's very important when I say named, and I'll get to that here in a second. A variable is a named storage location. So it's very important that I refer to it as a storage location. It's just a location, let's say your closet, where you can store things in it. You can put your clothes in your closet, but then it's important to note that you can go into your closet and take out a shirt. You can take out something from your closet, and then later you can put it back. So that's the important thing to note of a variable. It's a storage location, more specifically located on RAM somewhere, that you can store data into it and change the data at any time you want. So I call it a named storage location because you essentially attach a name to this location so that we can access the storage location without really having to go through too much trouble. We can just, whatever we call it, we can just refer to the storage location with that name. So the first thing we need to do in order to create a variable is that we need to go over this concept of data types. Data types basically just specify what type of data a variable can hold, and I'm going to give you some examples of them. So for example, let's say we have a number, the number 5. We need to store this in memory somehow. Our program that we're going to write needs to be able to remember the number 5 and maybe use it in some kind of mathematical equation later on or something like that. So one data type that we have at our disposal is the type integer. An integer is a whole number, meaning that it cannot hold anything that has a decimal. Only a whole number, 1, 2, 3, 4, 5. It can't hold 5.5. It can only hold a whole number. So to create an integer, we start by saying int. So we're saying that we're creating a variable called integer. Anytime you create a variable, at first it is the data type. So we're saying this variable is going to hold integers, only whole numbers. And then you have to give it a name. So I'm going to give my variable a name of, let's say, x. Just like kind of how math works. Or I'll say my int, actually, so it's a little bit easier to read. So I'm saying int my int. The word my int is an identifier. It's what I attach to this new variable so that I can access it later on. So I'm saying int my int. My int is the name of the variable. There are some rules with creating variable names, like it can't start with a number. There can't be spaces and things like that, and you can look that up. But for the most part, everything will be fine. Just stay away from spaces and stay away from numbers as the first character. So I say int my int. Now I want to give my int, which is a variable, some kind of value. So I'm just going to say equals 5. So a couple things are going on here. The equal sign, that's the assignment operator. And basically what the assignment operator says is anything to the left of it is going to be assigned the value of the right. So whatever's on the right, assign it to whatever's on the left. So since 5 is on the right of it, that means my int is going to be assigned the value 5. At the end of it, I have a semicolon. This semicolon is a statement terminator, you can think of. It basically just says that this is the end of the statement. So most things in Java are going to end in semicolons. And if I don't put a semicolon, I will get an error, so you don't have to worry about that. So what essentially I did here is I created a new storage location on RAM. My RAM stick now has a little allocated spot on it called myInt. It's not technically called myInt, but that's how we're going to refer to it to change the data and make it hold data in there. Another data type that we can mess with is a double. A double is another data type but besides, unlike the int, this data type can hold numbers that are decimals. So it can hold a decimal. So I'm going to say my double, I'm going to give it a name, equals 5.5, and that's perfectly fine. I'm giving the value 5.5 into my double, so now my double holds the value 5.5. Another type is a string, and strings are unique that we'll learn in the future, but strings can hold text, so like hello world in quotes. Any single time we deal with strings in or text inside of a programming language like Java, we have to surround the text with quotes. And the reason why we have to do that is because if we don't put quotes around this, the compiler or the Eclipse editor is going to search for variables that are called hello world. But we don't want that. We just want the text displayed. So when we put quotes around it, the compiler ignores it and treats it as text. So a string just can hold text, hello world. We also have a boolean or a bool. In most programming languages like Java, like C#, C++, you're just going to refer to it as bool. In Java, you say boolean like this. I'm going to say my bool. And a bool can hold either a true or false value. That's it. It can either be true, it can either be false. And we're going to talk about this a lot more later in this video of why bools are important. But yeah, for now, just note, bools hold either a true or false character. So there are more data types, and we're going to make our own eventually as well. But for now, this is a decent starting point learning programming. I note that when teaching a lot of people programming, it's always better to keep the data types as low as possible in the beginning because it can be confusing. So just giving you these 4 basic data types, you could basically almost cover all types of data already, and this is a good starting point. Another thing to note is that when you declare a variable, let's say an int, there are other types of data types that hold information that's similar to an int or a whole number. Like, for example, a short. A short is basically an integer, but it can't hold as big of a number as an integer. Basically, when you say int, you're allocating more memory on RAM because you're saying I could possibly hold a very large number. I think integers can hold approximately -2 billion to +2 billion. That's the number it can hold. So by saying an int, you're allocating memory big enough for the highest number possible. But if you know your numbers are only going to be 1, 2, 3, 4, or 5, you don't need an integer. It's wasting memory. So you could maybe use a short or a byte, something like that. Now, as technology advances, this used to be a lot more important back in the day because we used to have to, well, not me, I say we used to. This is what I'm told. They used to have to really be cautious of memory because there wasn't a lot of memory to use. But now we have so much RAM, it really doesn't matter for a PC. If you're getting into mobile development and making apps for iPhone, Android, Windows Phone, it's a little bit more important to just be a little bit cautious of your memory. But nonetheless, it's not that big of a deal for this. For a standard application, there are situations where it's very important that we need to keep memory down. But for now, don't worry about that. So here are 4 variables. So I want to point out that right now I would have 4 variables. They have some data in it. The one big problem I always see in beginner programmers is they have a hard time understanding when a variable is created and when you use one. For example, whenever I ask a question to a beginner programmer like change the value of my int to 10, for example, everyone they always go int my int equals 10, and they try to redeclare this variable or recreate this variable. And I always say no. You only say the data type of the variable when you're creating a new one. If I'm just using an existing variable, I don't say int again. I'm just going to say my int equals 10. I'm just referring to this current variable and changing the value of it. So I'm not going to say int again. That's only for creating the variable to hold the data. So I just say my int equals 10. And that's good enough. Now the value of my int will be 10. But you may be saying, oh, how do I know my int is 10 now? Well, I'm going to show you how we can print the value of a variable or text to this little console window down here. And we can put some text in here. So what I'm going to do is there's a command. For now, don't worry about the technical details of this. You will learn in the future. But for now, just copy. This is how we're going to print to the console. We're going to say system, capital S, dot, out, dot, print, ln, which stands for line, and then you open up parentheses, and then inside those I'm going to type in what I want to display. So if I wanted to display some text as a string, I could put quotes. I could be like, hello, this is some text. I could do that, end it with a semicolon. To run the program, I go to this little play button up here. I hit the little play button. I hit OK. And as you can see in the console, it says, hello, this is some text. But let's say I don't want to display text. I want to display whatever the value of my variable is. So I'm just going to type in, for example, my int. Now, we changed the value of my int here to 10. We started out as 5, then we changed to 10. So when we print this, we should see 10. As you can see, we do see 10. So this is the first example how I explained that a variable is just a storage location. We created a storage location called myInt that we can use throughout the whole program now, basically, and we can change the value of it at any time we want. So I changed it right here. So I changed it to 10, and now it goes to 10. If right after I say myInt equals 15, and then I run the program, it's going to say 15 now instead of 10, because 15 was changed last before I printed it out. If I delete these and then run it again, you'll see that it's just going to say the 5, like we started with. myInt equals 5. Now, I could print out any of these. I could print out my double and run the program, and this will print a 5.5. I could print my string, even my bool. I could print this as well. And it's going to say true, because that's the value is true. I also want to quickly show you, what if, okay, you're building a program, I want to print the value of a variable, but before that, I wanted to write some text. I want to say, maybe the value of my int is, and then put in the value, plug it in. So we would have to start off by having some text in quotes. We'll say the value of my int is, colon, I'll add a little space. Now we need to somehow attach the value of my int. Most programmers will be like, oh, I'll type my int like that. But what happens is, this is just going to print the value of my int is my int. It doesn't actually print my int because I'm putting my int inside of those two quotes. By putting in the quotes, the compiler treats it as text now, and now it's just plain old text. What I have to do is go outside the quote. I need to add a plus sign, and this is concatenation. This basically is going to combine a string and an integer together and print them out together. So here I'm going to say my int outside of the quotes, and now this will take the value of my int and print it instead of displaying the text. So now it says the value of my int, let's change that to int. The value of my int is 5. That is concatenation. We're plugging them together using the plus operator, the concatenation operator. But don't get confused. The concatenation operator is going to be used for math, like we're going to see here in a second. But when we're dealing with strings, it concatenates and combines them. So that's what happened here. So we messed with some variables. Hopefully you understand that a little bit. One thing before we go to arithmetic operators, like the plus, multiply, minus, divide, and modulus. One thing to note is these are variables. They can change. You can also make them constant. By making them constant, we use the final keyword. So I can say final int my int. By adding final, that means that this cannot change anymore. It's a constant value. My int will always be 5 if I make it final. You'll see uses of making things constants in the future. One example is pi. The built-in pi is a final because pi is not going to change, so we make it a constant. So that's how you make things constant. You don't have to worry about that too much right now. So now I want to talk about some arithmetic operators, and that means basically being able to do some math, adding, multiplying, dividing, and things like that. So what I want to do, I'm going to start off by saying int my int, and I'm going to say my second int, and this is going to be equal to 10. So I want to try to add these together and then store them into a new variable. So I'm going to say int answer. I'm creating a new variable right now. That's why I'm saying int. Int answer equals my int plus my second int. All I'm doing is I'm taking the first variable, dumping the value in, I'm taking the second variable, dumping that value in, and I'm adding them together. And then the equal operator, or the assignment operator, its job is to take whatever's on the right. So this is the right hand side. It evaluates that. So my int plus my second int, so that's 5 plus 10, 15. Assign that to whatever's on the left hand side. So answer will now be 15. So if I display this to the console by going system.out.println answer, and then now if I run this, you can see it says 15. So the plus operator just adds things together like you would expect. Let's try changing it to multiplication. So I'm going to change it to this little star, and that's multiplication. Then I'll go ahead and run the program. As you can see now it says 50, so it actually did multiply it. You could also do subtraction and division as well. As you can see, we get -5. So this is just adding some variables together using some basic arithmetic operators. Another operator is the modulus operator. So I'm going to say, let's make this, I don't know, 12. No, let's make this 12. The modulus operator is basically just a remainder. It just divides them together and returns the remainder. So if I make this the modulus, which is the percent sign, and then I run this, we're going to get the remainder, which is 2. It's 2 because 10 goes into 12 once, and 2 is left over. So that's the modulus operator, which is just the percent sign. It's just the remainder. Just remember modulus remainder. It's pretty simple. It first does the division and then returns whatever's left over. So a good question that I normally ask new programmers is, let's say we have my int equals 12. I asked you, how would I make the value of my int go up by 5? That means that whatever my int is now, make it go up by 5. And some of the answers I normally get is, okay, my int equals 17. Well, yes, that is correct. My int is now 17, but you didn't make it go up by 5. You just added and then assigned it a new value. And the reason why this is not practical is because most of the time you're not going to know what the variable actually is. For example, I'm not going to know that my int is 12. Maybe the user typed that in at runtime of the program. So I won't know that it's 12, so I can't just make it 17 because I don't know that. So I'll have to figure out a way how to make that go up. Another thing I normally see is my int equals plus 5, like this. And what this is doing is just saying my int equals 5. So that does not make it go up. So this is normally a very tricky task. I don't think I've ever encountered a new programmer, like brand new programmer like you are right now, who has gotten this question right. So if you do know the answer, then you are smart. So the answer to this solution is that you have to increment my int in terms of itself, because you have to use itself. My int is 12 right now. So if all we know is the assignment operator right now, the only way to make it go up by a certain value is that we have to use itself. We have to say that my int equals my int, or itself, plus 5. And by saying this says my int, okay, now whatever's on the right hand side will be assigned to whatever's on the left. So my int is 12, so it goes 12 plus 5, my int equals 17 now. So it takes whatever my int is and adds it by 5. Now the reason why I'm bringing this up is because there's other ways to do this. This is long, saying my int equals my int plus 5. It's tedious. Why am I typing my int twice? So because that's annoying, there's another operator that just is a shorthand for this. It's my int plus equal 5. And this is just a shorthand. Basically what it does, it combines the plus and the equal together and removes the extra my int. It basically just says, okay, I understand I'm going to add to myself 5. So basically it adds 5 to itself and then assigns it. So that's where the plus equal come from. It's just a shorthand for doing this. So whenever you see plus equal, just remember that this is really what's happening. It's saying my int equals itself plus 5. It's just adding to itself. So these all have the same operator. So times equal, divide equal, and subtract minus equal. So these are all the same things. They just are for incrementing like this. There's also one more way to increment by 1, and we'll talk about that in the future when we talk about loops, most likely. I'll tell you what it is now, and it's the plus plus and minus minus operators. If I go my int plus plus, that just increases my int by 1. It's just another shorthand. You could do my int plus equal 1 or my int equals my int plus 1. This is just a shorthand, again, for incrementing by 1 only. There's a little confusing topic with this about postfix and prefix, that the plus plus can go either in the front or the back of the variable, but we will talk about that probably in later videos. I don't want to confuse you too much right now. Okay, so good. We talked about variables and arithmetic operators so far, and then we did a little challenge with incrementing by a value. The next thing I want to talk about is using comparison operators. And to talk about comparison operators, basically we need to start with the bool again, the bool data type. So as you recall, Boolean, my bool, can only hold a true or false value. It's just like any other variable where you can change the value of it, but it's just that this type of data can only be true or false, and the memory for a bool is a lot smaller than an integer because it can only hold a true or false. Now, the reason why I'm bringing up bools again is because this is extremely important in the use of comparison operators, which will be used throughout your programming career. Comparison operators are very important. Comparison operators obviously compare things. And because a comparison only has two answers, essentially, a Boolean is a perfect candidate for holding that type of data. Now, let me ask you a question to show you what I mean. If I asked you, is 5 greater than 6? What are the two possible answers that could be? It's either yes or no. Is 5 greater than 6? Yes or no. True or false. 1 or 0. Those are the only possible answers. So when we ask questions like that, the Boolean data type is the best type to handle it. So comparison operators, whether it's greater than, less than, is equal to, or is not equal to, they all return either a true or false value. So let's try this. Let's say bool my bool equals 5 greater than 6, like I just said. So because greater than can only return a true or false value, I can do something like this. I can say my bool equals 5 greater than 6 because greater than will only return a true or false value. So it works fine. So what do you think the answer is? I'm going to say system.out.println. I want to pass in my bool. When I run this program, we should get our answer, and as you can see, it says false. It says no, 5 is not greater than 6. That is false. So that is a greater than. So that's one example. We have greater than or equal to, which is just like that. We have less than, so I'm going to run the less than one. And now you can see it says true because 5 is less than 6. We also have equal to, which is 2 equals. Notice how this is different than the assignment operator. The assignment operator, it does an assignment. It's changing a value, which is a single equal sign. The double equal sign is for a comparison. It is comparing two things. It can only return a true or false. So this is saying, is 5 equal to 6? No, know it's not. So that's false. And then we also have the not equal, which is exclamation point equal. And that means, is 5 not equal to 6? And that is true. 5 is not equal to 6. And as you can see, we see true. Now, I just wanted to quickly go over these operators to start getting you exposed to the concept of a Boolean expression. But they will be a lot more useful and apparent when we start talking about if statements. If statements are extremely important in programming. They allow us to make decisions like, if 5 is greater than 6, then do something. So we'll talk about bools a lot more then, and the comparison operators will come up again. But that's what I really wanted to show you right there. So another concept that it's pretty complex, but I want to introduce you to as of now, is this concept of casting. Because as you start writing software, even though we're going to write a calculator at the end of this video, which is not too far off. However, this could come up in your future programs. And it's important to at least have some kind of understanding. So the concept of casting. We talked about variables. We talked about data types. How data types can only hold certain types of data. So for example, my double equals 5.5. Doubles can hold a 5.5. That's a decimal. But however, I told you integers cannot. If I said my int equals my double, I'm trying to assign the value of my double to my int. So it's saying my int equals 5.5. And we are getting an error. The error is that we can't do that. And as you can see, the first solution to this is add a cast. And that's what we're going to do. So the concept of casting is basically converting from one data type to another. So the problem here is that we need to convert a double to an integer, and how it happens in Java specifically, even in C#, it just truncates, and what that means, it throws away the extra that an integer that can't hold. So it does not round anything. So if I convert a double to an integer, it's just gonna cut off the decimal. It's not gonna round it to 6. It's going to cut it off. So instead of it being 5.5, it will become a 5. And the way to do that is I have to force it into an integer, because it doesn't want to. The reason why it can't do it on its own, obviously the computer is smart enough to say I could convert this on my own, but it makes you do it yourself because it doesn't want you to lose data by accident. Because it is losing data. The 0.5 will be gone. So it doesn't want to just do that automatically. It wants to make sure that you consciously know that you are throwing away data, because an integer can't hold a 0.5. It can't do it, so we have to throw it away. So in order to cast, we're going to use parentheses in front of our thing that we want to convert. Inside those parentheses, we're going to put the data type that we want to convert to. So I'm saying treat this my double as an integer, and how the computer does that is just by cutting off the 0.5. So now my int is the value of my double as an integer. So let's go ahead and print out whatever that value is. System out print line, and we'll print out the value my int, and we should see 5 because errors exist. Where's my error? Print ln. Let's go ahead and run this. We should, and as you can see, we see 5. It cuts off the 0.5, and that is the concept of casting. It goes from when you have to do an this is called an explicit cast. It's explicit because we are specifically specifying the int. We're saying force this into an integer, squeeze it into an integer. So that's why it's explicit. There are also implicit conversions, meaning that the conversion will happen and there is no loss of data. For example, if I went the other way around, where I had my int equals 5, double my double equals my int. This is an implicit cast because it is converting from an integer to a double. However, a double can hold whole numbers and decimals, so it can hold everything an integer can, so there's no chance of losing data. That's why the compiler does not force us to do an explicit cast, because we're not losing any data. If I run my double, we will see that 5 still being stored there, so we're not losing any data. So 5.0, we didn't lose any data. So that's the reason why this is called an implicit cast, not an explicit cast. Okay, so that's cast. That's casting for now. We will see it most likely more in the future. What I want to show you, and this is important for the future of every video that basically we'll probably do in this fundamental series, is we need to look at, well, we wrote to the screen or to the console. Now we need to be able to read from the console, meaning the user types in a number. We need to be able to read that number and do something with it. So the way we do that in Java is we have to use a class. It's called a class called scanner. And until we talk about classes, it's not important that you remember, or it's not important that you understand what's going on, but rather that you just remember how to create a scanner. So let's start by saying scanner new, or my scanner. Now, before I go on, I'm going to get an error. And that's because scanner lives somewhere in the programming world that we are not using right now. So in order to use the scanner, we need to include we need to include where it lives so that we can use it. So the way we do that is we go to this error right here, we click it, and as you can see, it says import scanner from the Java util programming area. So when I do that, you'll see on the top of my code, it says import Java util scanner. And that basically now we can use the scanner. If I do java.util.star, that lets us use any class in the util class. In the util namespace. So we just want the scanner for now. So now we can use a scanner. So scanner my scanner just copy this down for now. You're gonna don't worry about the syntax. Equals new, we type scanner, and inside of the parentheses we're gonna say system.in. And this just means that basically we're gonna be listening to the system.in instead of system.out, which is writing to the console. We're gonna listen to system.in, which is reading from the console. So now we have a scanner. So once we have a scanner, now we can handle it. And now we can handle users entering data into the console. So let's start off by asking the user a question. We're going to say system.out.println, what is your name? So I'm asking them what their name is. Now I want it to actually get their name from the user. So let me start off by saying, what type of data type can hold a string? The answer, sorry, I just gave you the answer. What type of data can hold text? And the answer is a string. So we can say string first name equals, and we're going to say my scanner dot next line. And what that means is we're just going to get the next line of the console of whatever's typed in. So now we're saying first name, we created this new variable of type string. First name is now equal to my scanner.next line. So whatever is typed in will be stored into first name. Now that I have whatever is typed in, now I can use it. So I'm going to do a print out. I'm going to say system.out print line. Hello. I will say hello there from we'll say hello there from, actually let's just say hello there, and we'll plug in their name. So remember how we plug in a variable? We go outside the quotes, we do a plus so we can concatenate, and we type in the thing that we want to plug in, which is the first name. So we're saying hello there, first name. So whatever was typed in as your name, we're storing that into a variable, and then we're using that variable to print some dialogue. So let's go ahead and run the program. So it says, what is your name? I'm going to say Jesse. I'm going to hit enter. And now it says, hello there, Jesse. So it took whatever I typed into the console, it stored that into my first name variable, and then when I plugged in the first name variable, it took whatever I typed in, which was Jesse, and then now it displays, hello there, Jesse. So that's how we read in from the console. So that's the basic example. Now let's get to what I wanted to do this entire lesson, which was let's make a program that's actually sort of useful. Let's make a basic addition calculator. So if you're a new programmer, this is a big step for you. This is a milestone in your programming career. You are going to learn how to make a calculator. Screw using Microsoft's built-in calculator in the operating system. We can make our own. Oops, sorry about that. We can make our own. So let's start off with, we're going to leave our scanner. We're going to need our scanner still. But we're going to start off by saying to the console, system.out println, enter your first number. Okay, so what data type can hold a number? Well, that would be an integer. Int first number equals, now my scanner. Remember, we're using the scanner to read whatever is typed in. Instead of using next line, we're going to use a function called nextInt. NextInt just gets the next number that's typed in. So my scanner.nextInt. So whatever number was typed in, that will be stored into first number. Then I want to repeat. I want to say system.out.println, enter your second number. The second number is entered. Now I'm going to create a new variable. This is going to hold the second number. So int second number equals my scanner.nextInt. This will just get the next int that's typed in. So now I have two numbers typed in, stored into my two integer variables. So int my second number equals my scanner.nextInt. This will get whatever's typed in, and we'll dump it into second number. Now I just want to get the answer, so I'm going to create a new variable called answer, and that's going to be equal to first number plus the second number. So I add those two together, and I have the answer now. So now I have the answer. We created a calculator. Now I'm just going to print the answer to the console. So system.out print line, I'm going to say the answer is colon, then we're going to concatenate the plus, and I'm going to dump into the console the answer of whatever first number plus second number is. So whatever was typed in for the first number, I'm going to add that to whatever's typed in the second number with this statement right here, and then we'll just display it. So let's go ahead and run this program. We just created a calculator. So enter first number, 15. Enter your second number, 25. Hit enter. The answer is 40. It took our two numbers, added them together, and printed them out. So we built our first calculator. You should be extremely proud of yourself. If you can understand everything in this right now, you successfully completed this lesson. That's what I wanted you to get out of this first lesson. I always with new programmers start with building a calculator. I think it is the most basic type of program that you can make, and it's cool. You know, you made a calculator, and if you really want to spend a lot of time, you can make a calculator that adds, multiplies, divides, subtracts, and everything. So yeah, we made a basic calculator. I want to go one step further and just make it a little bit nicer in the printing out here. We're going to use a little bit more concatenation, and I'm going to say first number, so whatever was typed in the first number. Then I'm going to add a plus sign. So that plus sign as text, so that it displays the plus sign. Then the plus sign outside the quotes to concatenate again. So first number plus second number. Then I'm going to do another one to do the equal sign inside the quotes. So the first number plus the second number equals the answer. So all I did here was I just broke up all the variables and added plus signs. So now when I run it, it's going to actually look like it's doing some math now. So it's going to be like 15 plus 25. And as you can see now, it says 15 plus 25 equals 40. By using concatenation, I added these plus and this equal sign, and then I dumped in the numbers, and then it built a calculator. So I believe that is it for this first lesson on the fundamentals of Java programming using data. I think I'm calling this this lesson using data because we're just interacting with data. So this is going to be the fundamentals series. We're going to cover, it's probably going to be about, like in my C# series on my free channel, it's probably going to be about 8 videos long, give or take. So yeah, this is the first one. If you understand this, you're good to go for the next lesson. The next lesson, I believe, let's see, is on making decisions, which is basically using if statements and changing the flow of the program. So I hope that you enjoyed this video. I hope that you actually learned something from it. And I hope that I maybe could have sparked your interest in programming to show you that it's not that hard. It's a very empowering task, and I hope you all who started this continue with it. So thank you for watching. Be sure to stay tuned for the next video in this series.